Hello guys, welcome back to my channel. So today let us see the real numbers second exercise. Today we will be completing this chapter. So let's see the first question. Prove that root 5 is irrational. So they are asking us to prove that root 5 is irrational. To do this, first we have to do this only by using contradiction method. Contradiction is nothing but we are assuming a statement that is contrary to the question. So let's start. So to prove this, we should use contradiction method. Let's see. So I'm selecting this contradiction method. Contradiction. So now let us assume that root 5 is rational. Okay. Let, let us assume that the statement is more important. Let us assume that at root 5 is rational. So if the root 5 is rational, then root 5 will be equal to a by b, where a and b are co-prime. A and b are co-prime. So why we are writing that root 5 is equal to a by b? Because a rational number can be expressed in the form of p by q, where q is not equal to 0. So we are assuming in contradiction that root 5 is rational. So we are writing in the form of p by q. Instead of p by q, you can write a by b also. So let us go to the next step. Now we are squaring the first equation. Squaring LHS and RHS. That is root 5 whole square is equal to a square by b square. What is the root 5 square? That is 5. So a square by b square. Now we are taking b square in the LHS side. I'm changing the color. So 5b square is equal to a square. So now let us take 5 to RHS side. If it is in multiplication, it goes by division. So b square is equal to a square by 5. So from this we can understand that b square is equal to a square by 5. So if we take a square by 5, we can say that if a square is divided by 5, then a can be divided by 5, yes or no? See, let us assume that a has 5. If y square is divided by 5, then 5 is also divided by 5 or not, yes or no? Yeah. So 5 square 25. Just take for example, if a is equal to 5, then a square will be equal to 25. So if a square is divided by 5, then 5 is also divided by 5. So this is the thing. I am just saying this as an example, not there is no value for a in this sum. So now let us go continue. Now let us write the statement. If is 5 divides a square, then 5 divides a, yes or no? So this is the first part of the answer. Now let us start with the next part. So note it down in your book. I am just erasing it for my clear space. Okay. Now let us go to the second part. We have proven that a square is divided by 5 and a can be also divided by 5. Now let us go to this is the sum actually. Actually we got this as a final one. We have proven that a square can also be divided by 5. Now if see, we got this only right. We have already told that Wait for a second. Okay. B square is equal to A square by 5. This has been proven earlier. So if 5 divides A square, and the 5 also can also divide A as well as A. So we have proven that already. So if we take A by 5, we will be getting some value, right? See, A by 5 will be getting some value. So let's take that value as C. So A by 5 is equal to C. This is the value. We'll be getting some value. If we divided the A by 5, we will be getting some value. So we are taking it as a variable as C. So if we take 5 to the RHS, we'll be getting as A is equal to 5C. So this is our the second equation. So we should use this equation, A square is equal to 5C. This is the second equation, second important equation. So uh, so let us take normally 5b square. Actually this is our first equation, 5b square is equal to A square. And now okay, I'm just marking it. This is the first equation we got. This is second equation. Okay, so now we are applying A value in A is equal to 5C in the place of A square. So 5C the whole square. Since it is A square, we are squaring. So 5b square is equal to 25c square. Is it right? Now we are taking 5 to the RHS again. B square, sorry, we are taking 25 to LHS. So it comes in division. That is equal to c square. So 1 5s are 5. So c square is equal to b square by 5. This is third equation. So from third equation I am just erasing it, so please note it down. Okay, so this is the equation we got. Okay, c square is equal to b square by 5. This is the one we got. Now so we have already told that A square by 5, we have proven 5 divides A square as well as A. Similarly, we can also say that if 5 divides B square, then 5 can also divide B. Am I right or wrong? Yes. So similarly, A square by 5, we are saying that B square by 5. So 5 can divide B square as well as B. So if 5 divides B square, then 5 also divides B. So statement is more important in the sum. There is no mathematical calculations in the sum, only by proving contradiction and writing statement gives you more marks. So we have proven that. This is the third one, third equation. Sorry, third statement, important one. Okay. Now we have proven that A square by 5 and B square by 5. Both 5 can divide both A as well as B. Am I right or wrong? So we can also write B by 5 is equal to something, some variable. Okay, so this is not as much as important. Now let's go to the statement. Okay, so 5 divides both A and B. So both A and B, sorry, so both A and B, has common factor as 5. So next statement would be, but this contradicts that contradicts that root 5 is rational. Earlier, we have said that root 5 is rational by contradiction. So, we have said that A and B are co-prime. Co-prime means they don't have common factor more than the number itself as well and 1. But in this one, we have A and B, two numbers. In both the numbers, we have 5 as common factor. This cannot be possible if it is a co-prime, but it has common factor as 5. So coprime will have only 5, it's the number itself as well as 1 as its factor, but the A and B has a common factor as 5. So since it has common factor, A and B cannot be a coprime. So our assumption is wrong. Our assumption is assumption is wrong. And the concluding statement would be, so root 5 is irrational. Okay, this is a concluding statement, hence proved. So in this state, the second sum is to prove that 3 plus 2 root 5 is irrational. So in the first sum, we have proven that root 5 is irrational. So no need to prove again that root 5 is irrational. So in this sum, we should proceed first by proving that root 5 is irrational. First, we should prove that root 5 is irrational. We have proven that in the first sum, so no need to worry. You can try it on your own. So we have proven that root 5 is irrational. So we have to write, given after proving that root 5 is irrational, you should write the statement root 5 is irrational. But in certain sums, the given itself will be the root number will be irrational. They will be given in the question sum for some questions. So for that, you no need to prove again. So this would be a statement. So let's jump into the sum. We know that root 5 is irrational. Okay. So let us say in the same manner, I have given some important statements in the last slide. So let us take the same steps. First, assumption. Let us assume that 3 plus 2 root 5 is rational. So we know that rational number can be expressed in the form of p by q. So 3 plus 2 root 5 is equal to a by b, where a and b are co-prime. So this one we knew what is co-prime. They don't have more than one, the number itself and the one as their factors. So now let us take all the numbers except the root 5 to RHS. So we are leaving alone root 5 in LHS and taking all the numbers to RHS. So root 5 will be equal to a by b. So let us take one by one number. So 2 root 3 is equal to minus 3. So I am just taking first number 3. So then 2 root 5, taking LCM, we will be getting a minus 3b by b. So this will be your LCM after taking LCM. I am just erasing, note it down. Okay. So we got that 2 root 5 is equal to a minus 3b by b. This is the one we got. Now taking 2 RHS again. So just leave root 5 alone in LHS. So root 5 is equal to a minus 3b by, since it is in multiplication with root 5, if it goes to RHS, it will be in division form, 2b. So we have got this. This is an important one. Now we know that root 5 is equal to a minus 3b by 2b. So since we can say that the RHS is rational because all are in the a minus a by ab. So if we assume any of these numbers, it will be RHS will be a rational number, because if you minus or plus it is in a rational form, right? So we cannot say that RHS is irrational. We knew that a minus 3b by 2b, it can be divided and minus subtracted, so it is in a rational form. So we can say that since RHS, so in place of RHS you should write the value. Since RHS is rational, we can say root 5 is also, or LHS is also rational. But this contradicts the given statement that root 5 is irrational. We have proven that root 5 is irrational, but here we are saying that root 5 is rational. This is a contradictory statement. So now we are concluding this sum. So that is, this contradicts the given one. This contradicts that root 5 is irrational. Yes or no? Because this statement contradicts that root 5 is irrational. Contradiction means opposite saying. So this contradicts. So we are concluding that our assumption is wrong. So therefore 3 plus 2 root 5 is irrational. Hope you understand, hence proved. So let's jump into another sum. The second exercise of this chapter is fully consists of only by contradiction methods. We have to prove all these sums. In this exercise only we have proving sums, that is contradiction. So I'll say some important statements that are required. Only if you write all these statements you will be getting full marks. So I'll say the important statements, you just note it down. Okay, I am writing the important statements. So starting statement would be, let us assume that, this will be our first statement. Let's assume that some root 3 or the given irrational number, something they would be given, like let us take example of root 3 as let us assume root 3 is rational. So you have to write the full form. Since I don't have space, I am writing in short one. So second statement would be, then the given number equal to, that is root 3 is equal to a by b, and we have to write where a and b are co-prime. So you don't worry, I will be giving this in the description. All the statements in the description. The third statement would be squaring on both the sides. Squaring. The fourth statement would be, there is no calculation in the sum, you have no need to worry. So only the statement plays an important major role. Okay. Next, the final concluding statements would be, in the middle there would be some divisions and squarings that you must take care. The statement alone I am saying. The fourth statement would be, both the numbers have common one factor as the given number, something as 3. Now the fifth statement would be our assumption is wrong. Assumption is wrong. Therefore, finally, the final statement would be, therefore, root 3 is irrational. So take a screenshot. These are important statements. I will give you in a description. Okay. So let's go to the second sum. So now we came to the last question of this chapter. So third question, with this we'll be concluding this chapter. So this is the easiest chapter. So let's go. Okay. So prove the following are irrationals. So we have to prove that the given numbers are irrationals. So first one, 1 by root 2. So let's start with first sum. You can also try in your notebook. 1 by root 2. Prove that 1 by root 2 is irrational. So this we have to prove it. So first sum. I'm sorry. So we have to prove that 1 by root 2 is irrational. So this is the first one. So let's jump into the answer. Okay. This is the given number. This we have to prove into rational. Prove that 1 by root 2 is irrational. So this we have to prove it. Now let's prove in the same method. You should just mark it up the given statements. I have given some important statements, right? So that you have to mark it up. So it's obvious. So let's do the answer. Okay. First, let us assume that 1 by root 2 is rational. So by this time you must have to know the statements. So we know that if it is rational, then 1 by root 2 is equal to a by b, where a and b are coprime. So this is the first statement. So as well as first we have to take the root. In the questions there will be some root number, right? So here root 2 is the variable. It is the single number. So we have to keep the root 2 number in LHS and take all the excess numbers to RHS. Since here root 2 is in divisible form, we have to take in a numerator form. So to do this, we are changing LHS to RHS and RHS to LHS. So if it changes its position, it will be in reciprocal form. Am I right? So if we change this into this and this into this, here to here and here to here, we will be getting reciprocals. So b by a is equal to root 2. See, we have got this. So first we have to prove, for the sums we have to prove that first we have to prove root 2 is irrational. So in the first sum we have proved that root 5 is irrational. Same way you have to prove that root 2 is also irrational. So after proving that you should do all this sum, all this statement. So this is second part. Actually first part is to prove that root 2 is irrational. So I am going directly. You can do on your own, or you can refer from the previous slides. So we have got this statement. Okay, we have got this one. Now Since we can also change like this, root 2 is equal to b by a. So b by a is a rational number, am I right? Since it is expressed in division form, it is a rational. Since b by a is rational, we can say root 2 is also rational. So am I right? So, but this contradicts that we have proven that previously root 2 is irrational. That you have proven, I am not proven. So you have to prove that root 2 is irrational firstly, and then we should do the second part. So we know that root 2 is irrational, but this contradicts the statement. See, we are now saying that root 2 is also rational, but this contradicts that root 2 is irrational. So now we are writing that this contradicts that root 2 is irrational. In bracket you have to write proven. Sorry, given. First you have to prove it that given given. So we are writing it. Next we are writing or assumption is wrong. Therefore 1 by root 2 sorry therefore 1 by root 2 is irrational. So hence proof. Let's go to another sum. Second subdivision of the last sum of our first chapter. So second sum is prove that 7 root 5 is an irrational. So we have to prove that 7 root 5 is irrational. First you try in your notebook. Let's see. Okay, now let us try. Hope you got the answer. Let's see. So the given number is 7 root 5. To prove that is irrational. Prove that PT means prove that. Okay, it's a short form of prove that. So we have to prove that 7 root 5 is irrational. The same way we have to use the assumption. Let us assume all the statements play an important role. For all these type of questions, the statements are same. Only the numbers are different. So it is easy to remember. Let us assume that. So 7 root 5 is rational. All these type of questions are same format. You no need to worry. It's not like other chapters like calculating complex calculations. Not like that. Only you have to remember the statements in this exercise. So we have said that 7 root 5 is rational, assuming. So if it is rational, then 7 root 5 is equal to a by b, where a and b are coprime. A and B are coprime. The statements in bracket are also important. If you won't write these statements, they will cut some marks. Your teachers. So we have said that it is rational. Now we are keeping that root 5 in the LHS and 7 to RHS, because we are keeping the root numbers alone in LHS and taking all the constants to RHS, so that we can use a contradiction method and prove that the given number is irrational. So root 5 taking 7 to RHS, a by b minus divided by 7. Since it is in multiplication with root 5, it comes to division. So we know that this number, I am writing again, root 5 is equal to a by 7b. So we have got this. So we can write here It is RHS is whether it is rational or irrational. Obviously, it is rational. So we can write since A by 7b is rational, then root 5 is also rational. So rational. So actually I am not proving the first part. This all these sums are actually I am doing second part, because first part takes some time. So firstly you have to prove that the root numbers in the questions like 7 root 5, first you have to prove that root numbers like root 5, root 3, all these we have to prove. Firstly these numbers are irrational, then only you should go to the sum. So I'm just taking the second part. First part is we have to prove that root 5 is irrational. We have proven that root 5 is irrational in the first sum itself. So I'm skipping that state sum problem solving. So I'm doing this just second part. First part you try in your notebook, or you can refer to the previous sum. Okay. Now we are concluding the statement. Since a by 7b is rational, then root 5 is also rational. Now we are writing, but this contradicts that root 5 is irrational. This we have proven in the first part given. So therefore 7 root 5 is irrational. So hence prove. Let's go to the next question. So third question is to prove that 6 plus root 2 is irrational. So let us prove that prove that 6 plus root 2 is irrational. This thing we have to prove now. So first part is to prove that root 2 is irrational. We have to see only first step is to see the root numbers. The number which is under root, we have to prove that it is irrational. Then only you should go to the question is irrational. So you know to prove that. So I am skipping the first part. So I am directly jumping to the second part. Okay. The second part is let us assume. So in first part we have proven that root 2 is rational in the first part. Now jumping to the second part, by assumption, let us assume 6 plus root 2 is rational. Then 6 plus root 2 is equal to a by b, where a and b are co-prime. So we have taken this. Now keeping root 2 in LHS and taking the 6 in RHS. So the number which is under root, you have to prove that first it is irrational, and then the second part you have to keep that number under the root in LHS and taking all the constants to RHS. So root 2 is equal to a by b minus, since it is in plus with root 2, if we take to RHS it will be in a symbol of minus. So minus 6. Taking LCM we will be getting a minus 6b by b. Okay. Now we have came to concluding statement. Since say a minus 6b by b is rational, then root 2 is rational. I am erasing this, just note it down. But this contradicts but this contradicts that root, wait for a second, root 2 is irrational. This we have proven in the first part. First part is to prove that root 2 is irrational. We have proven that. Sorry, you have proven that. Given. So, our assumption is wrong. Assumption is wrong. Therefore, 6 plus root 2 is irrational. So finally we have completed this real numbers chapter, easiest chapter. So subscribe to my channel, share this chapter to all your friends who are thinking maths as a toughest subject. So tomorrow we will get to the next chapter, that is polynomials. That is another easiest chapter with 2 exercises. It is completed within 1 hour, 1.5 hours. So bye bye, take care, bye.